Okay, so in this video we're going to look at some algebraic, let's say fractions. I printed a list here, but I'll just, obviously that's a bit little, so I'll just kind of rewrite them. So the first one up here is 5x minus x squared all over 25 minus x squared. So obviously how I kind of usually see these is we can't cancel anything or reduce anything out because we have multiple terms. So with these you want to usually go and kind of factorize. So at the top I see there are two x's that I can take out. That's common factors. And then what's left here is 5 minus x. So if I had to multiply x times 5, I get 5x, and x times negative x would give me negative x squared. So that part's done. And this is kind of a special case. It's a difference of squares. So 25 is a square number, and x squared is obviously a square number. So with the difference of squares, I kind of just make my brackets. I take the square root of 25, which is 5, and the square root of x, which is x, and just make sure the signs are different. And now I'm at a place where I have one term at the top. Sorry about that. One term at the top and one term at the bottom. And these can just cancel out. And I'm left with x over 5 plus x. And that should be good enough. Okay, my second example here is, I'm just going to quickly rewrite it. Let's do this in a different color. We'll do 3 over x minus 5 minus 7 over 2x. And they say write, just see the example here, write as a single fraction in its simplest form. So to have a single fraction, I need to kind of get them on the same denominator. So if you remember, if I had maybe 2 over 4 plus 1 over 3, I can't add those because the denominators aren't the same. So I can get the denominators the same by kind of finding a common factor. So usually you just end up multiplying these two things. So 3 times 4 is 12. So I can multiply with 4 on both sides and 3 on both sides. And 3 times 2 would be 6 over 12 plus 4 over 12. And now suddenly I can get a 10 over 12. So we're going to do the same thing right over here. I'm going to do it in different colors just to make it look a lot easier. So I'll write this part of my fraction as is, and then I'm just going to add my whatever I'm multiplying, 2x, 2x. And if you look at this, these should reduce to 1 and then be left with that. So this is exactly the same thing because 2x over 2x is 1. And then I'm going to do the same on this side and write my fraction 2x and just color code. Obviously you don't have to color code. In this case I'm obviously multiplying with this denominator, so I'm going to have x minus 5 on this side and x minus 5 top and bottom. So you see those things are the same. So you would note that the denominators are the same. So now I can just kind of write everything on the same denominator, which is x minus 5 and 2x. Okay, I can multiply that out or just leave it in factor form. That's all good. But I have to kind of do this whole thing now. So 3 times 2x is going to be 6x. And now this negative 7, I kind of have to remember it's negative 7 times x. So that's negative 7x. And it's negative 7 times negative 5. So that would be negative times negative is a plus. And then that's going to be 35. And these are like terms. So I'm going to be left with negative x plus 35 all over x minus 5, 2x. Different versions of the answer can just be switching them around, like 35 minus x all over, I mean, you can multiply these out even and have 2x squared minus 10x. Let me just check. X times 2x is 2x squared, and then minus 5 times 2x is negative 10x. So, I mean, these are all the same. It doesn't really matter about the order or anything, but this is kind of where you want to end. Okay, let's take the next example. I'll put in a link in the description below so you can find this paper. Next one is just a simplify. So they give us 4x squared minus 16x all over x squared minus 16. I kind of like these examples, especially this. I love the difference of squares. But yeah, again, we can't reduce anything to 1 or simplify because we have multiple terms at the top, or well, 2 terms at the top and 2 terms at the bottom. So you'd remember if you had x plus 4 over x, you can't cancel or reduce to 1 these x's because there are 2 terms at the top and one term at the bottom. So for this, I have to get 1 term and 1 term, and then I can start reducing. So first of all, I'm going to try and see if there's anything common. So the 4x I can see is common. So 4x times x would give 4x squared, and then minus just 4 would work because 4x times minus 4 would give negative 16x. And here at the bottom is difference of squares. So I would just make my 2 brackets again, put my x's there because x times x is x squared, and then 16 square root is 4. Just make sure the signs are different, and now I can see that and that's going to reduce to 1, and I'm left with 4x over x plus 4. Okay, let's do the next one. Ooh, there's a little, what is this? Equation 1 over x plus 1 plus 9 over x plus 9 is equal to 1. Now I kind of really like it when we have equations, because with equations you can just kind of disregard. You can let your, I can say, your fractions you can let them disappear, if I can say it like that. So for example, if I had something like 2 over 3 plus 1 over 2 is equal to 5, then I can make these fractions disappear by, if I were to multiply by something like 6, every term multiplied by 6, then obviously 3 will go in itself 1 and into 6 twice, and then 2 times 2 would give me 4, and then the same here, 2 would go in itself once and into 6 times 3 times, so I'll have 1 times 3, which is 3, and 6 times 5 is 30. Now obviously this is not the same thing, but the point is I can make these fractions disappear just by multiplying with a common denominator. Okay, so in this case I'm just going to multiply with, let's write it in a different color. Where is my marker? I had it here. Let's try green. I wonder if the green works. So I'm going to multiply everything by, let's write it like x plus 1 times x plus 9, x plus 1, x plus 9, and x plus 1, x plus 9. There we go. So everything I'm going to multiply, and if I multiply this and that, this and this would cancel out, and I'll be left with the 1 times whatever is left there, which is x plus 9, and then plus the 9, and what's going to cancel here is the x plus 9 and the x plus 9 will cancel out, and I'll be left with the x plus 1. And here everything is just, it's 1 times that, and I have to multiply everything. So x plus 1 and x plus 9. Okay, if I look at my paper, I see there I have 2 answers for this question, and it makes sense because I have a equation and it's going to be a quadratic equation at the end, so obviously I'll have 2 answers. I'm just going to expand the brackets. I'm going to do it in a nice blue color, so let's do, that's x plus 9, and this becomes 9x plus 9 again, and on this side you can do the FOIL, which is x squared plus 9x plus 1x plus 9, and I'm gonna take everything over to that side. So I'll start with x squared is here, but let's just do, I'm gonna not work too fast, but let's just look at this. So this is x, and this is 9x. So that's 10x. Sorry, I just need to reach to the computer screensaver for some reason. X plus 9x is 10x, and if I take that over, it's going to be negative 10x. And this is 9 plus 9, which is 18. If I take it over, comes negative 18. Or you can see it as, okay, I'm taking 10x, subtracting 10x off this side and 10x off the other side, and taking 18 off this side and the other side, which is fine. And then, okay, so that one is already there. And then I have a plus 9x here, plus a 1x, and plus a 9. And then the minus 10x, and that is plus 10x. That's going to kind of cancel each other out. So I'm going to be left with x squared minus 18 plus 9 is going to be minus 9. Oh, very convenient. Difference of squares. And I actually know already what's going to happen here, but it's x plus 3, x minus 3. So x is going to be either negative 3 or x is going to be 3. Okay, simples. So trick here is kind of removing the fractions by multiplying with, anyway, something you multiplied and got from there. Okay, cool. Let's take a look at our next question. Next one is number 5. Simplify the following. So we have 2x squared minus 5x minus 12 and 3x minus 12x. Okay, so at the top here I have a trinomial, but the coefficient of x squared isn't 1. So there's a cheat. I'll show the cheat afterwards. So let's just think about how we usually do this. If I were to multiply 2 and 12, I get 24. And I need to find some, factors of 24 that's going to get me 5. And that is going to be 3 and 8. So 3 and an 8 will get me to 5. And now I just kind of have to rewrite the top part. So I'm going to write 2x squared. And to get to 5x, it will probably be negative 8x plus 3x. So these two would together give me a negative 5x minus 12, and all of that over 3x. I think that's a squared. I made a mistake. 3x squared minus 12x. And now I'm just going to factorize this as a 4 term. So I take a 2x out, and I'm left with x minus 4. And there I'm going to take, what am I doing? Let's take a plus 3 out, and I'm left with x minus 4. And all over here, I'm going to take out a 3x, and I'm left with x minus 4. Well, lots of x minus 4s here. And eventually, it's going to be x minus 4 and 2x plus 3 all over 3x, x minus 4. And these would cancel out, and I'll be left with 2x plus 3 over 3x. Cool. The cheat that I can quickly show you for this is if I were to, let's write it there, 2x squared minus 5x minus 12. If I multiply it by 2, then I do, again, this is just a little, it's a math trick. And then this is easier to kind of factorize. So then I have my normal x's as usual, and I know 24 and 5, so it's going to be a 3 and an 8 as usual. And then this is going to be a negative 8 and a positive 3. But because I multiplied by 2, I'm going to divide by 2 on both sides now. And this 2 I'm taking to the front, so it's 2x plus 3. I made a whole video on this, x minus 4, and let's just see 2x minus 3, 2x minus 3, that's the same, x minus 4, x minus 4. So this is a different trick. I did make a video. I think I'll put a link below as well. Hopefully I remember to put in all the links. But it's just kind of a easier way if you don't want to take this long method. Just make sure you always test your answer when you do this. Okay. Okay. What is next? Let's say it's quite a long video today. Ooh, nice. This is very cool. So I have 2x squared plus x minus 15. Again, a trinomial with a 2 in the front. Ax plus 3a minus 2bx minus 6b. Okay, so I'm gonna do my cheat sheet. Well, let's say my cheat here. I'm gonna say x squared plus x minus 30. So basically I just multiplied that coefficient in there. Can't see that. There we go. And then I'm gonna write my x. And I know this is 5 and 6, and I have to get to a positive number. And then because I multiplied by the 2, I'm gonna divide by 2 on both sides, and that doesn't divide nicely, so I get 2x minus 5, and this is x plus 3. Okay, so the top would factorize to 2x minus 5. You can use your own method. That one is just works easier and quicker for me. The bottom here, it's obviously 4 terms, nothing is common, but I see those a's are common and those b's are common, obviously the 2 and the 6 as well. So for this, I'm going to have to take out an a, and I get x plus 3. Very conveniently that there's an x plus 3 there. And then I'm going to take negative 2b out, and I'll be left with x x plus 3, because minus 2b times plus 3 will give minus 6b. So I'm still left with x minus 5 over x plus 3, 2x minus 5 I mean. And then here I'm left with x plus 3, a minus 2b, and then these will just cancel out, and I'm left with 2x minus 5 all over a minus 2b. 2x minus 5, a minus 2b. Okay. There we go. Okay, let's see, next one. Another right as a single fraction. Now it's not an equation, so we can't just let the, remove the fractions. X plus 2 minus 2 over 3x minus 1. Okay, so I'm going to rewrite this as 1, let's say x plus 2. I'll just do my different color here just because I have to put everything on the same denominator. So 3x minus 1, 3x minus 1. So I'm basically just multiplying both sides, top and bottom, with 3x minus 1. And then this part becomes 2 over 3x minus 1. And on this side I'm multiplying, where's the other color? I feel I had a red here somewhere. There we go, found it. And on this side I'm just doing x plus 2, x plus 2. So you see this is also just kind of 1. And now I just kind of do the top. So I expand, that would be 3x minus 1. And I have minus 2x, and minus 2 times plus 2 is just going to be minus 4, all over 3x minus 1 and x plus 2. And then like terms I can just do, so 3x minus 2x is x minus 5, so minus 1 minus 4 is minus 5, all over 3x minus 1, x plus 2. You can probably multiply these out if you want, but I'm just too lazy. This should be good enough. So yeah, there we go. Let's do our next one. Close to the end, 3 more to go. Oh, nice and simple one here. I have a x to the power of 3 plus 5x squared all over x squared minus 25, similar to a previous one we saw. And here I'm just going to take out x squared, and I'm left with x plus 5. And here is a difference of squares. So that's x and 5 and 5, and just make sure the signs are different. And then I can see those cancel out or reduce to 1, and I'm left with x minus 5. Okay, I think that's good. Yeah, so we have 2 more left. Okay, this one. Oh, someone's yelling at the background there. Sorry about that. A squared minus b squared. Just some simple factorization, getting a b out. And then a minus b. And this is difference of squares. A minus b, a plus b. And those cancel out. And I'm left with b over a plus b. Nice. Okay. And now for the last one in our paper. So 2x squared minus x minus 1 over 2x squared plus x. Again, this is kind of a trinomial with a coefficient of 2. So I'm looking for a number that, well, is going to multiply to 2 and add up to -1. So obviously I'm going to have a 2x and an x, and it's going to be a 1 and a 1 because 1 times 1 is 1. So now I just have to figure out where the signs go. So if I have to get to a -1x. So this will have to be negative and that positive, because if I multiply 2x with x, I get 2x squared. And then if I do this part, I'm going to have 1x, and that's going to be -2x. And -2x plus 1x is going to be that -x there. So there we go. And here I'm going to take out an x, and I'm left with 2x plus 1. Conveniently, it cancels out, and I'm left with x minus 1 over x. If you want to be, I think that's fine. I think that it just said simplify, so I'd leave it like that. But alternatively, something like x minus 1, both are over x, so it can just be 1 minus 1 over x as well. But I would just leave it as like this. Cool, thanks for watching. Hope that helped you.